Welcome to the Black Sparrow Media Internet Broadcast Network.
You are listening to Linux in the Ham Shack. LHS is a podcast about Linux, open source, and amateur radio for everyone. Now here are your hosts, Russ, K5TUX, Cheryl, W5MOO, and Bill, NE4RD.
Well, hello everybody and welcome. You have tuned in to episode number 448 of the most terrific amateur radio podcast on the internet. This is Linux in the Ham Shack, and this is our deep dive episode, and it's a real good one tonight, so you definitely want to stick around for everything that's going to be said. But before we dive into it, we'll go ahead and introduce ourselves. I'm Russ, K5TUX. Cheryl, W5MOO, is on assignment tonight, but we do have...
I'm Bill, NE4RD. Good evening.
Excellent. So, yeah, we have a topic that's kind of been bandied about in amateur radio circles since the very beginning of the hobby, and somehow we have only now gotten around to talking about it. There's probably a million YouTube videos about it. There is a presentation probably at every ham fest that's ever happened about it, and we are finally going to talk about it. And from what I've gathered so far, if you ask 20 people what the proper way to do this is, you'll get 20 different answers. So hopefully we'll get some definitive answers, or if nothing else, add to the noise. But I think this may be the first time that we've asked an expert on about a topic who literally wrote the book on it. So we'd like to bring in our guest for tonight. His name is Ward Silver. His call sign is November 0 Alpha X-Ray. And if I understand correctly, he's just a little bit up the road here in eastern Missouri from me. So that's also cool. But he has written a book about grounding and bonding in amateur radio. And that is our topic for tonight. So, good evening, Ward. Thanks for being here.
Hi, I'm glad to be here. Sounds like we do have a topic. And I got to correct you. If you ask 20 people about the topic, you'll get 25 answers, because by the time you get to the 20th one, the first one and the first 5 will have changed their minds.
I'm not surprised. That's sort of what everyone has said. Oh, you want to talk about that? Well, you're going to get answers, and you just kind of have to layer them on top of each other and shake them through the sifter, and whatever falls out the bottom, that's what you go with.
Yeah,
so,
occasionally it gets to be like the Monty Python complaints and abuse confusion, but, we'll work it through.
All right. So we are talking about station grounding and bonding, and you literally did write the book on the topic. It's an ARL publication, I think, and I don't remember the exact title, but it's something like Grounding and Bonding in Amateur Radio or something like that. And so why don't you give us a little bit of your background in the hobby and how you got to the fact that you wound up writing this book?
Okay, well, it's called Grounding and Bonding for the Radio Amateur, so you're pretty close. And the second edition just came out with new and improved content over the first. I've been in the hobby. This is my 50th year. Next month will be the 50th anniversary of that magic envelope coming from not the FCC, but the Little Print Shop, which was a QSL vendor, and they got the call signs before the licensees did. So I got an envelope from the Little Print Shop and had the strange combinations of characters on it. And I looked at it and went, wow, I'm WN0GQP, but I had to wait another 2 weeks for the actual license to show up. So I've been at this a while, and part of the deal when you read all these books, because you really don't know what you're doing when you get into this, no one does, was they had to put a ground rod, and you just had to do that. That was important. It didn't really tell you why, but that was part of the deal. So by golly, I did it, and I hooked a wire from that to my radio at Heathkit HW16, and I couldn't tell any difference. I didn't notice when it fell off sometimes or anything, but it was just something a ham ought to do. So that was what I did, and that was my introduction to grounding. And then I went off and got an electrical engineering degree and got into instrumentation and a bunch of other topics. And grounding and bonding is pretty doggone important, but it takes a long time to really understand what's going on. So part of what I was doing for the ARL was writing a QST column called Hands on Radio. And all those columns are available to members on the website or in a book form. But in 2016, I wrote 3 columns, beginning with one called The Myth of RF Ground. That led to more correspondence than anything else in the 15 years of my writing that column, 180 columns. And this topic just blew my mind with the questions and the interest. And I started looking up some of the answers, and the information was spread out all over the place. Some of it's in the handbook, some of it's in the antenna book, some of it's in this book, some of it's in that book, some of it's online. And it didn't all agree, and it all had different jargon and stuff like that. So I went to the publications department, Steve Ford, WB8IMY. I said, Steve, we need to collect this information and bring it together, and it would make a great little book. So a few months later, we had a great little book, and I got to acknowledge that I am not particularly a deep expert on any of the types of grounding and bonding that are covered in the book, but I had really good reviewers. I knew approximately what was going on, and they really kept me out of the ditches and really got the information correct. So I got to thank those guys, Ron Block from Polyphaser, Dale Svetnoff, who's a lightning consultant, Jim Brown, K9YC, the ARL lab. All those guys were really, really helpful. So that's where the book came from. It tries to bring enough information together in one place and present it consistently so that a person putting together a mobile or a home HF station can ground and bond correctly. And for those of you who are interested in the VHF and up, it points to a lot of additional resources where you can go find out how to do that too. So that's the story, and I'm sticking to it.
All right, very good. And we're going to sort of dive into the topic, but Bill did the wonderful thing of putting all of your accolades in here, so we definitely want to mention some of these. Like, you have been the lead editor of the ARL handbook and the antenna book. You've been awarded Amateur of the Year by Hamvention, so that's pretty cool.
Yeah.
And you're in the CQ Contest Hall of Fame, among other things. So you are really deep into this hobby.
Well, yeah, 50 years will do that.
Fair enough.
People ask me how I got into it, and my mom would drop me off at the library, which was the internet of the day, when she was running errands or something for my brothers and sisters had to be done. And so I would wander around, and one day I found a copy of QST, and you know how the movies have it when somebody opens a book and the light comes up, from the book and shines on their face and their eyebrows go up. That was kind of how it was for me with QST. And I thought, wow, this is something I really want to do. So that was it. May 1966 copy of QST, and it took several years after that to find somebody to help me learn the Morse code and get into it. And the rest is history.
Very good. You've also authored 3 Dummies books: Ham Radio for Dummies, Two-Way Radios and Scanners, and Circuit Building, which is excellent because, speaking just for the host of this program, you're in good company. But anyway, there's 2 questions I wanted to ask before we get into the actual topic, which hopefully by way of asking them, we'll sort of get into the topic before I touch on my upcoming project here. The first is, I've talked to a lot of amateurs who are in the same situation as I am, that they don't really have any grounding or bonding, or at least they have not done anything intentional to have such. So one, and you can answer this in either order, but the first question is, do you get anything by setting up a shack as far as grounding and bonding accidentally? And two, what are the dangers of not doing anything?
Well, let's see. Let's take two first. Let's say you don't do anything. You just, it's typical. I mean, you get your license, you buy a few boxes, you put them on a desk or a table or something, and you plug them into a power supply, you run wires all over the place and bring in a cable for your antenna, and everything pretty much works. The radios are well enough designed to work in that kind of environment. And everything works just fine for a while, and then you start getting complicated. Maybe you want to do digital modes, or you want to switch your audio between several different devices, or you want to add a keyer or something. And all of a sudden you have these weird hotspots, and maybe the station stops working on some bands. If you run more than 50 watts, the computer resets, and things like that. Or maybe you've got hum or buzz or something. Well, that's a problem. So then you're like clipping things together with clip leads and wires and frantically looking in books and trying all this random stuff. And maybe you get it to work and maybe you don't. So that's part of why you want to tackle this problem, kind of knowing what you're doing. And it's not that expensive, really, to do this properly. As a matter of fact, when you're at the stage where you have a couple of boxes on your desk and stacked up in your operating, when you decide you want to do that, that's actually a pretty good time. You can just take the boxes off the desk, set up your grounding and bonding, and put them back on the desk. It's a lot better to do it then than after you get really involved with a lot of gear. And the second one, the first one was, what would happen if you didn't do anything? Was that your first question?
Yeah,
Sorry.
The first question is, what are the dangers of? And the second was, do you get anything by accident?
Right. So you can get a lot of things by accident by not doing it. But then you can kind of lurch yourself into having a serviceable station, but there can be quirks. Are there dangers? Well, not very many people get electric shocks anymore because of the way power supplies are constructed and things. But you can, particularly if you start adding things like amplifiers or high power DC supplies, you can create electrical shock hazards. So you definitely want to make sure everything's grounded. The big issue that everybody has, at least in the areas of the country where you have thunderstorms, is lightning. Even if you don't get hit by lightning, you've got your station all kind of set up, and then there's a big storm, and there's some lightning around, and maybe something was close but didn't hit your station, so you're thinking, wow, got away with that. But then you go over and, wow, my USB cable doesn't work anymore, or gosh, my radio, it didn't turn on, or the computer got popped, or something. Lightning, even an indirect strike, can cause a lot of problems just because of its big magnetic field, and that will induce a lot of voltage into conductors like cables in a ham station. Plus, you really don't want to be in the station when there's a thunderstorm around. So I wouldn't suggest that just by grounding and bonding you can operate right through thunderstorms, although I've done it by accident and gotten away with it. But just because you get away with something doesn't mean it's properly designed. So you get peace of mind, you have fewer failures of equipment, unexplained resets and things like that. AC safety is important, lightning protection is important, and sometimes it involves building codes and insurance. So you want to make sure that even if it's not physical damage, you don't want to get financial damage because you haven't gotten something properly permitted, or your insurance adjuster comes over and goes, oh, I can't insure this because you're not up to code, or something like that. There's a wide spectrum of possible problems dealing with this, and it can go all the way from actual electrical shock or fire all the way to simply inconvenience and problems with paperwork. So there's a big spectrum of things. I hope that answered your two questions.
I certainly believe it did. It probably answered them better than the questions were. So I guess we can move on and talk actually about grounding and bonding at this point, and maybe get into some best practices and stuff. And there's a bullet here in our show notes about the 4 types of grounds. And I think the first one is the best to lead off with because it isn't specific to amateur radio, but it does affect all aspects of dealing with electricity, and that is just electrical system safety grounding and or bonding. So maybe you can talk a little bit about just how your house is grounded, things like that, before you even think about putting a ham radio on the air, and like the important factors there and what you want to consider when making sure that you're set up to be grounded properly in that space.
I believe that boils down to what's the deal? Okay, so we have to back up a little bit. And when I give a presentation on this, the first thing we talk about is the definition of what is ground and what is bonding. They're two different things. We tend to talk about them in the same sentence as if they were the same thing, but they're not. So let's talk about grounding or ground. If you look at the word ground, it has wildly different meanings. It can be a noun, which means ground is an earth connection, an actual connection to the earth. And if you're talking about AC safety or lightning grounding, then that's what ground is. It's a connection to the local reference voltage or potential, and that's the circuits and RF meaning of the word ground. It can be a verb, which means I'm going to ground this. What that means is I'm going to connect something to the reference voltage. And it can be an adjective, which is a type of connection, such as a ground conductor or a ground system. So you can use all 3 types of the word in the same sentence and can mean all these things at the same time. You hear things like, I'm grounding the chassis to ground with a ground wire. And I've heard people talking to each other about grounding, and they're both nodding up and down and all that. And I listened for a little while, and I realized they're talking about completely different things. But the word ground, you have to be careful when you use it because it means different things at different frequencies, at different, whether you're talking about safety, whether you're talking about lightning protection, whether you're talking about just trying to keep everything at the same voltage, all that kind of stuff. So you have to be careful when you use the word. And there's a couple of sort of myths about ground, fuzzy definitions and things. First of all, the earth, meaning your backyard or whatever. It's not a magic 0-volt sink into which you just pour your lightning or RF or whatever or noise and just expect it to magically disappear. Same thing for vehicle bodies in a mobile station. The earth is a big complex circuit, just like your antenna farm. And so you have to understand what the earth is and is not. It's a big resistive mass. And you have to understand why, for example, lightning wants to get there so badly. It's because of the imbalance in charge between what's upstairs and what's in the earth. So you have to be aware that the earth is resistive. And if you're trying to dump a lightning size amount of current into it, you have to help it along with the ground system. And then there's fuzzy definitions. I hear this all the time, the words RF ground, which started off the Ham Radio for Dummies article. There ain't no such thing, okay? There are only local reference voltages. You can make something 0 volts with respect to something else. And it's not going to be 0 volts with respect to something else over a very wide frequency range because of transmission line effects and electrical length of conductors. So I try to steer people away from using the term RF ground. I'll qualify that a little bit. The ground plane that you would have for a vertical antenna, for example, ground-mounted vertical, where you run the radials out. That's a different kind of ground system. That's a return path for current from the radiation from the vertical, but it's not a ground in the sense of this discussion. Another thing is ground loops. they're really not the problem you think they are. The ground loop came out of audio and AC wiring, where you don't want to have, in the case of AC wiring, you don't want to have big loops of conductors that can be excited by error currents in the power system. So you wind up with lots of amps in a big loop. So electricians talk about ground loops because they want to make sure they only have one reference voltage in the power system that keeps you from having shock hazards. Audio folks want no ground loops because a big loop of wire, if it's got a magnetic field going through it, like a 60 hertz power or something, will pick up a signal, a voltage from the magnetic field. And if there's a loop, it'll induce a voltage in that, and the current causes hum. And so you don't want this kind of a loop around a magnetic field if you're an audio person. Single point ground is another term that you hear a lot. That depends on the frequency. Single point, the word means electrically small. And at AC, the electrical wavelength at 60 hertz is about 50 million meters, if I recall correctly. So electrically small can be something the size of a football stadium and still be a single point ground. But basically the idea is to connect everything to the same point. Now, that depends on frequency. If you're talking about very low frequency stuff, that can be something very large. But as you go up in frequency, the wavelength gets smaller until at 2 meters and up. Single point ground is something that can only be inches or centimeters or millimeters large. So it depends on frequency. And all the different set of requirements, AC safety and lightning and RF management, have different types of requirements. So you have to be careful about how you use the word ground. And then the other thing is bonding. What is bonding? And if you look it up, bonding is a connection intended to keep 2 points at the same voltage. That's it. Doesn't say what that voltage is. It can be 1,000,000 volts. It can be 0 volts. You bond systems together in an airplane. That's not at 0 volts with respect to the Earth. I have not seen an airplane dragging a chain. So, they don't do that. But they bond everything together. They want everything to be at the same voltage. And in your station, when you bond stuff together, so that there's no voltage between the pieces of equipment, everything goes up and down together. It's kind of like a floating dock where you tie your boats to the floating dock, and when a big wave comes by, everything goes up and down together, and the boats don't tear themselves off the dock, or the dock doesn't break and things like that. You want everything going up and down together, because when there's voltage between pieces of equipment, there's current. That's what causes current, is voltage differences, and current is what does the damage or causes the interference in your station. So you want everything bonded together to short out any potential voltage differences, and also ground loops. Any conductive path that makes a loop is a ground loop. And if you go back and look at the back of your ham station, almost any ham station is going to have dozens, if not hundreds, of ground loops, and there is nothing you can do about it. Any RF cable or audio cable with a shield that connects 2 or more pieces of equipment together is going to make a ground loop. So what you do is you bond stuff together. It prevents shock hazards. It prevents destructive voltage differences caused by lightning surges, and it limits the current between the devices caused by RF pickup, for example. And so it does nothing but good things in your station. It keeps you safe, protects you from lightning, and it cuts down on RFI, which is caused by current, and the current is caused by voltage. So remove the voltage differences, and you're going to do yourself a world of good. And it sounds hard, but it's not. You're just using wire and strap to connect things together. It sounds expensive, but it's not. You don't have to weld things or use special clamps for the most part, all this kind of stuff. That number 14 that you got in the box because you refused to throw any piece of wire away in your entire life. Well, this is a great opportunity to use it. If you're outside, it does require the right connecting materials and hardware, but bonding works in your favor for AC safety, lightning protection, and RF management. And for bonding to work, I'm kind of running on here, but I'm in my definition mode here. For bonding to work, it has to be low impedance and it has to be short at the frequencies of interest. That means you don't get strange transmission line effects, and the bonding has such a low impedance that if a little current flows through it, it doesn't cause a voltage. And it also has to be heavy enough to carry the expected current. If you are bonding things together and you think they might get hit by lightning, you have to use seriously big wire and clamps and all that kind of stuff. Number 12, number 14 gets hit by lightning. It'll make a very nice green lightning bolt, and that'll be the last you see of it. And it has to be sturdy enough to survive the environment. If you have buried radials in your backyard, for example, they have to be heavy enough that when you hit them with a shovel or dig them up with a rototiller, don't ask me how I know this. They need to be strong, so you go, oh, I hit something. And then you go, oh, it's ground wire. And then you put it back in the ground. If you use small stuff, frost heaves, driving over it, hitting it with the shovel, all that kind of stuff will break it. And then you don't have the connection anymore. So it needs to be sturdy. And there are rules about how big things have to be in your building code if you're going to pass code inspections. So follow these rules. They're important and they will help your grounding survive. Inside the station, what I tell everybody is use heavy wire, number 14 or larger. All that scrap Romex and stuff is just perfect for this. Or use standard for military and commercial. Get some 20 gauge strap. It can be copper, it can be aluminum. You want solid, heavy, low impedance connectors or conductors. And what if you want to use braid? Okay, well, you can use that flat weave tinned braid, the silver stuff. If your equipment moves around, mobile stations, this is an issue. But do not use braid anywhere that it can get wet or anywhere that it's exposed to corrosive chemicals of any sort, which typically means outside. And the reason is that the minute water gets in between those little tiny wires, they start to corrode. And pretty soon you don't have a nice low impedance conductor. What you have is a zillion little conductors all making terrible connections with each other. And so it's a noise machine at that point. Do not use exposed braid from old coax. The instant you take it out of the jacket, it begins to deteriorate. Oxygen gets to it, water gets to it. The little conductors start to loosen up. They're only held together by the jacket. So the minute you take the jacket out, the jacket off the braid, the braid begins to deteriorate. If you want to use old coax as a ground wire, leave it in the jacket. Make a nice pigtail at each end and waterproof it, put a terminal on it, and just treat it as a big wire. But you have to protect braid from moisture and chemicals. Now, we've all got plenty of heavy wire and whatnot to use if you can get some surplus. Roof flashing, that kind of thing. And there are vendors that sell strap and braid out there as well. So you can really do a good job with what you have on hand in that big box in the garage. So that's what we talk about, grounding and bonding. So now that's the end of the definitions phase. And if you want, we can go on to AC safety grounding. That's an important topic.
Yes, we definitely want to move on to that, but I want to see if I have some level of comprehension of what you've just said. I want to summarize this all very succinctly, and you can tell me where I've gone wrong. But would it be safe to say that an electrical system, i.e., like a bunch of ham radios and stuff, would be properly grounded and bonded if all of the parts of the system are synchronized with reference voltage?
Well, synchronized is a time term. I would say if they are bonded together, it doesn't matter whether they're connected to a specific voltage or not. You just want them connected together. For grounding, you want that, whatever that connection is that connects all your equipment together, you want that connected to your AC safety ground, which is the common point in your power system, and you want it connected to an external ground system for lightning dissipation.
So is an electrical system in a house, for example, like whatever your 200 amp entrance is connected to, is that not already grounded per se?
Per se. Well, it's grounded from the standpoint of AC safety, but that doesn't do anything for you much for lightning protection, and it certainly doesn't do anything for you for RF management. So, yes, it is grounded, and you can connect your station ground or your station bonding bus or whatever you want to call it, and connect that back to your AC service common point, which is in the service box where that comes in. We can talk about that in a minute.
All right. Well, you were sort of leading right into the safety grounding thing, so let's go ahead.
Okay. All right. So depending on where you live in the country and how old your electrician is, grounding for AC safety is called equipment ground. That's the standard way that the National Electrical Code, the NEC, refers to it. But it's also called third wire ground or green wire ground. The important thing is to keep your ground connections for AC safety grounding low resistance. It really doesn't matter how long they are. Remember, the wavelength that we're talking about here is 50 million meters, so it doesn't matter much whether it's 6 feet or 100 feet. And there's only two reasons to do this. One is it provides a path back to the AC common point in your power system for fault currents, meaning short circuits, leakage currents, stuff like that. It's so that hazardous voltages and currents don't appear where a human can get to them, or worse, get between them, so that you would have a voltage between your hands, for example, or between a hand and a foot. And then all these earth connections, if you go off and you look at your, if you take off the panel in your circuit breaker box and you look at the breakers and the wiring, you'll see a couple of buses where all the white wires are connected, that's your neutral bus, and where all the bare and the green wires are connected, and that's your ground bus. Ground bus is connected directly to the metal of the service panel. And then in there is a big heavy wire that goes from the neutral bus over to the ground bus, and that's called the main bonding jumper. And you only have one of those in your house or your apartment or whatever. And then from the ground bus or from the metal of the box, you'll see a big honking wire. I think that's the official name for it, big honking wire, that goes outside and connects to a ground rod. And the latest standard is 2 ground rods, 8 feet apart, 8 feet long, driven into the earth. There are some exceptions. Some places in deserts and mountains, they use a thing called oofer or slab grounds, where they use the conductive concrete of your building to act as the ground electrode, and they bury copper wire in that, and that forms one big electrode. It's amazing. Concrete is really quite conductive, especially if you have many square feet in contact with the earth, and that's why you never ever want to work on energized equipment in your bare feet standing on the garage floor, because you'll get a shock. You don't want to do that. So anyway, what comes in from the power pole most of the time is it's called 2-phase. You'll see 2 big black wires. Those are the output of a center tap transformer on the power pole. And then 1 bare wire, typically, sometimes it's insulated, but the bare wire is typically neutral, and that's the center tap of the transformer. The center tap, if you go look at the power pole closely, you probably have a ground wire that comes down the pole from the secondary of the transformer and goes into the ground, either through a ground rod or it's wrapped around the bottom of the pole. It's called a butt wrap. And it's not a very good ground, but there are literally thousands of them at every power pole or every third power pole or something. And that connects all of the AC power systems common points to the earth. and that helps stabilize the AC power system voltage during faults and transients such as lightning and trees falling on lines and stuff like that. But what's inside your house, the AC service common point is that metal box that holds all the circuit breakers, and it holds those two buses, and it has that big honking wire that goes to the ground rod outside. That is the single point AC ground, and you want to tie everything in your station back to that has exposed metal on it. Even unpowered equipment like coax switches. So typically, if you look in the handbook or something, you'll see the recommendation that you use the standard is a piece of copper pipe in back of all your equipment. Use a nice short heavy wire to that piece of copper pipe, and the copper pipe is connected to your AC service ground, and that certainly satisfies AC safety grounding requirements. How's that sound?
Well, that sounds good. So if someone was going to do that, like me, who hasn't, so you're talking about having some sort of a copper bus bar or something, and then like just the ground coming out of an outlet, for example, or are you talking about some more direct connection?
Yeah, you can connect. Let's say you put down a piece of copper pipe behind your equipment, and you're saying, okay, what do I connect this to? Well, if you look in the box, the service box to your AC, if you've got metal conduit supplying it and a metal box, you can connect it to the metal box there. You can also connect it to one of the screws that holds down the outlet. Also, the center screw that holds the plastic cover over the outlet is also grounded, and those are perfectly good grounds. Another possibly better way to do it is to use a big heavy 3-wire cord that goes to a power supply, and then tie the enclosure of the power supply, which is also tied to the big heavy power cord, to the ground right there. So everything would have a common connection right at the power supply, and then there would be a big heavy cord that goes and plugs into the ground wire. But do verify that you do have a ground connection in your AC system. There are little testers, and you can open up the service box and you can look in there and you can see if there's a bare or a green wire.
All right, very good. Something I'd never even considered before. So is there anything else you wanted to touch on as far as electrical safety grounding before we move into other kinds of grounding?
Sure. I think the easiest thing to do, I think most of us are fairly, reasonably skilled, or we could run a branch circuit back to the box, or, wire up power supply or something. But once you get out of your expertise, your experience, and that happens really fast, I suggest that you get a how to wire a house type of book. And there are several out there. The one that I recommend right now is available through the big box stores and from Amazon and all sorts of other things. And it's from Black & Decker, and it's called The Complete Guide to Wiring. And I think it's in its 7th edition at the moment. It tells you how to do everything you're ever going to need to do in wiring a house. It'll tell you how to wire up all these new gadgets that are available for smart homes, what you can and cannot do with grounding. Like, should I ground my gas pipe? Can I use my gas pipe as a ground? The answer is no. But, can I use cold water pipes? Can I do this? Can I do that? How do I properly ground stuff? Especially important is when you decide to put in a sub-panel, like in your garage or your basement, and even more important if you do it in a separated outbuilding like a garage. There are special rules for grounding sub-panels and outbuildings, and I suggest that you follow them, because if you do not, you can create a significant shock hazard, and people are electrocuted every year accidentally because a sub-panel was not properly grounded. And they are different than your main service ground boxes. So follow the rules there. And if you're just not 100% sure that you've done it right, just hire an electrician to come in for an hour or two and inspect your work. It can save you huge amounts of time and trouble. It could save you from having a fire hazard. And I keep reminding people, your local building code is the law. And if you're in violation of the building code, you can be liable if you cause a hazard, or if somebody gets hurt, or if you have a fire, you can get in trouble with your insurance company, et cetera, et cetera. So get one of these How to Do It books. They're up to date. They follow the NEC. Check with your local building code. Hire somebody that knows what they're doing. Not that expensive, and it's peace of mind.
All right, excellent. I just wanted to point out here that a lot of this information is sort of U.S. centric, and Darren, one of our listeners from Australia, said that you might want to just make sure about your wiring, because like the jacketing and stuff is different colors in different countries and stuff like that. So
yeah, you have to follow those rules about color, and the British, for example, call it earthing instead of grounding, and they have their rules. So all these rules have been thought up after many thousands of hours of engineering time and many disasters and problems and stuff. And people say, how did this happen? Once they figure it out, they figure out how to mitigate it. And it's not for nothing that the National Electrical Code is published by the National Fire Prevention Agency. So that's from over 100 years ago, when it was a real problem.
all right. Well, I'm gonna sort of flip the script here a little bit, because the next type of grounding, I think we need to touch on third, not second, because I think the first one leads into this next one, which is common reference potential, or chassis grounding. So maybe you can move from electrical safety grounding into chassis grounding, because it kind of sounds like it's associated, or at least adjacent, for sure.
Yeah, they are. That's more of an RF management topic. Do you mind if I talk about lightning protection first? It's sort of a nice transition.
Okay, well, that's great, because that'll just like sort of flip everything backwards. So sure, why not?
Okay, well, we're moving up the frequency scale here. We've been talking about AC, which is 50 or 60 hertz. And so now we're talking about lightning, which is everything from DC up to about 10 megahertz. So it starts to become an RF event, okay? And then eventually we'll get to the RF in our stations. So here's your lightning strike. It's coming from 50,000 feet up in the air. You can't steer it, but what you're trying to do is help Mr. Lightning make good decisions, okay? So what does Mr. Lightning want? It wants a heavy, direct path to the earth to dissipate the charge in the ground and get rid of that charge imbalance. And because lightning is an RF event, and because it's a changing current that changes very, very rapidly, then inductance is more important than resistance. So you want to make things short, you want to make them wide, so they have less inductance. And all of these paths for lightning should be outside your residence. You don't want to make it easy for lightning to go through your station on the way to the earth. Give it this heavy direct path outside. And so the standard way of dealing with this is where all of the cables come into your station, just like your AC power has a service entry where it goes into the circuit breaker box. Then what you create is an entry panel, and that's typically what you call a single point ground panel. And you put everything on that. You put your lightning arresters on it. You put your data or phone service box protector on it. Your rotator or control lines or your switches, the protectors for those go on this single panel. And you even put a big surge protector for your AC power on it. You put this on the outside or close to the outside of the building, and then you connect that to the ground system that you built outside with ground rods and wires and things like that. So when the lightning comes, and even if it's not a direct hit, even if it's just a nearby hit, or maybe it hits the power system somewhere, it comes down your feed line or whatever, and it comes to this panel, and it's just like any other current. It looks for the lowest impedance path to where the voltage difference is trying to get it to go. And the voltage difference in this case is trying to get it to go to the earth. So you want the heavy direct connection from this panel to ground rods and your ground system outside the house. And that's basically how you try to protect yourself outside with lightning protection. Now, inside, what you're trying to do is bond everything together so that when the lightning current surge comes, and it can be a significant amount of current, even if it's not a direct hit, so that everything goes up and down together. And you don't want a piece of equipment A being at several thousand volts different from piece of equipment B, even if it's just for a second, even if it's just for a few milliseconds, because lightning moves really fast and electricity is really fast. And you want all of the ground systems in your house connected together as well. So the ground system for, say, your home entertainment system isn't at a wildly different voltage because of the surge from, say, your computer system, from your shack, from whatever else. This is when you hear stories about somebody saying, well, I was sitting in my room during a thunderstorm and I was minding my own business. I wasn't touching anything. And there was a big flash outside and suddenly this big green arc jumps from my computer system to my VCR. And now absolutely nothing in the house works. And that's because the ground systems were at different voltages. And while that surge was going on, those systems, those different pieces of equipment wound up at wildly different voltages. So for lightning protection, what you want to do is tie everything together in your station, and wherever you want stuff to be protected, tie it together and tie it to a ground system. And I'm oversimplifying drastically, but there's a very good series of 3 articles in QST that are available for free to everybody. They're 2002, and the author is Ron Block, B-L-O-C-K. And they're available on the ARL website. You can search them, or you can go to the safety page and you'll find them there. Definitely good. They explain what lightning is. They explain how to approach lightning protection in your house. So that's basically the idea with lightning. Low inductance connections, connect everything together, and then connect it to a ground system that is outside your house. Don't run feed lines and ground wires through crawl spaces and attics and all the other stuff. Give Mr. Lightning the path to the ground outside the house. And I'm kind of blowing through this and oversimplifying, but those are the high points for lightning.
Now, does that ground system, should you bond that to the house ground system as well, or
Yes.
should that be separate?
Yes, and that is a rule that all ground electrodes and anything stuck in the ground for the purpose of grounding outside your house, the word is shall. And if you've ever done contracts, there's no wiggle room with shall, okay?
Right.
They shall be bonded together. And so what you do for hams, what I recommend is just go outside the house and put in ground rods every 10 or 15 feet, whatever, around your house, connect them together with number 6, stranded or bare wire, stranded or solid wire, and you bond them together. And you bond that to your AC service panel ground. Remember the big honking wire that comes out of the circuit breaker box. You want to bond to that. You want to make sure that everything that comes into your house, not only your feed lines and stuff, but your telephone service, your data service, your telephone, your cable TV service, all of 3 of those, if they're not the same provider, if a different group comes and puts those things in, they all have a requirement to have a ground electrode. All of those things have to be bonded together, and they have to be bonded together outside the house. And that's so that when you get a surge from lightning or something, everything goes up and down together, and you don't get big voltage differences between the different parts of your system. So so you want this all bonded together outside the house.
Well, Bill, you were wrong.
I didn't know. I know.
That's why we're learning. Because that's what I said I was going to do with my antenna installation. And Bill's like, "No, you don't do that."
Yeah, you definitely want to bond it all together and outside the house. And yeah, you do want a ground rod outside your station if it's on the first floor or in the basement or something. But that's got to be bonded to all the other connections. So, it's all in the book.
All right, excellent. So it sounds like I might be purchasing a book here before too long. But
yeah, it's a lot cheaper than replacing a computer, I'll tell you.
Well, yes, I can imagine that. So are you saying by implication that like just plugging electronics into your electrical system in your house is not creating a bonded environment?
Nope, not
okay.
Only at AC. okay, only at 50 or 60 hertz. And they're kind of bonded together, but not once you start getting up above 100 kilohertz. And when these connections start to become electrically significant, you get all kinds of timing differences and voltage differences and all sorts of stuff. So you want to bond them together as close to the equipment as you can. And in the station, if you're ready to talk about what to do in the station, what I tell people is just put a piece of sheet metal underneath all your equipment. Just cheap aluminum flashing will do. If you've got copper, that's fine. Just lay down a piece of sheet metal, put the pipe on top of that, clamp it on good, and then use short wires to connect all that stuff to the what's called the bonding bus, the RF bonding bus, and that bonds them all together.
All right. Well, I think we're ready to move into the chassis grounding and antenna grounding. So, I think you can just roll into that and address it however you want to.
Okay. Well, I guess, let me see here. I have some notes, so I'm not making all this up just for me. Okay.
It's coming out of the ether.
Yeah. Oh, is that what that is? Yeah. Okay. Very good. Okay. So anyway, when you talk about chassis ground, that kind of thing, this is part of a bigger conversation where you're dealing with RF, and you're talking about signal ground and digital ground and analog ground and all this kind of stuff. And I want to separate the right off the bat. I want to go back and say the radials out at your antenna, if you're using a ground-mounted vertical or something. It's called a ground plane, but it does not have to be connected to ground. It's just something for the energy radiated by your vertical to induce current and flow back to the feed line of the antenna and not have to flow through the dirt. Okay, it's sort of a ground screen. So that's not really part of your grounding per se. They can be grounded. You can have a ground rod out at your vertical. That's fine, but that's not technically what I'm talking about here. Okay, so when you talk about RF management, which is really what's going on here, you have to realize that everything in your station is an antenna. I mean everything. So your tuner, your feed lines, your little coax jumpers, all these bonding wires, your interface cables to your PC, the power connections, the power supply, your AC safety ground, everything is going to be part of your antenna system. Hams, particularly in HF, you're not very far from your antenna. If you got a 40-meter dipole in the backyard, what's the wavelength of 40 meters? 40 meters, okay? It's 120 feet, all right? So everything within 120 feet is in the near field of the antenna. Actually, it goes farther than that. And so if you've got a city lot and you've got an HF antenna on it, everything in your house is going to be in the near field of the antenna. So it's going to pick up RF. And the more you want something not to act like an antenna, the better antenna it will be, right? Okay. So you just got to plan on everything in your station is going to pick up RF on it. Okay. So is that a problem? Well, it could be a problem if that causes current to flow into, say you're running a digital mode and you've got your radio microphone input connected to the sound card outputs of your computer. Okay, that's a high impedance, relatively high impedance, very low voltage connection. It doesn't take much to mess with that. Okay, it's a microphone input. So if you get RF picked up on that wire, it's going to have a voltage from end to end, and that's going to cause a current to flow. And the current is what causes the problem. It's not the voltage, it's the current. So what are you going to do about that? Okay, well, you got to short out that voltage. And the way you short out that voltage is bonding, okay, as we talked about before. So you're going to ground that computer, you're going to connect that to your bonding bus, you're going to connect your transceiver to the bonding bus, you're going to connect everything to the bonding bus with electrically short connections. So they have everything's at the same voltage. Whatever that voltage is, it's going to be at the same voltage. And if you've got an amplifier you got to pay extra attention to bonding. It'll show you where your weak spots are, okay, the minute you light it up the first time. But the idea is to create this common reference plane. That's what that sheet metal is underneath your equipment. Some stations build the station on metal shelves or a metal desk, or they use the like restaurant shelves. You've seen them; they're made out of metal mesh. That's great. That's perfect. That keeps it's this giant, big, common reference plane, so that all you got to do is connect your equipment to this metal, and it tries to keep it all at the same voltage, keep it all close together and connected together, and that will minimize the amount of voltage and current that's flowing between the pieces of equipment. So what do you get out of that? Okay, well, you get rid of hot spots. What is a hot spot? A hot spot is it's always at the end of the microphone. So you pick it up and you key down, you start talking, and you get this RF burn off your lip or your nose or something. The hot spot is caused because it's got lots of voltage on it compared to something else. Okay, so you want to minimize that. You want to get rid of that hot spot. You do that by bonding everything together, and that also reduces the buzz and the hum in your audio, whether it's a digital signal or your voice stuff. And it also reduces RFI caused by common mode current that gets picked up by these cables and conducted to various pieces of equipment. And it means you don't have to move stuff around to operate on one band. Or, better yet, you can move the equipment all over the place. Say you want to rebuild your station. You don't have to worry about, oh gosh, I had this all arranged so I could operate on 15 meters. Well, if I move it around, it's going to be weird on 15 again. But if you tie it all together with a bonding bus or reference plane, then that problem tends to go away. So the standard picture is you see this big pipe or something in the back of the equipment, and you use wire strap or braid if you have to, ground clamp to this pipe, and then the strap goes off to your single point ground panel, what we talked about, where all your feed lines come in, and it's also connected to your AC safety ground. And that's kind of the gold standard in ham radios to get all that done. Have an entry panel that's grounded, your single point ground panel, have all your station stuff connected together, and then have that connection between all the equipment tied to your AC safety, and have some kind of external ground system that has a nice big area for dispersing charge from lightning, and it'll keep everything connected to the earth like it's supposed to. So hopefully that's helpful.
So do these for like cables for like floating devices, I'm thinking specifically like, the little signal link boxes and stuff like that plug in USB on one end and then, digital interface cable to the other. Yeah. And those things aren't really, they're metal boxes, but the board itself is actually not bonded to the box. It's just slid in on rails.
Is
using like clip-on ferrites on those cables any use, or
is
that just like is that like myth or science or what?
No, it's science. It's sort of hit or miss. Ha ha. This is a huge problem with inexpensive electronics, and hams can't afford to buy military grade electronics. You just can't. Okay, so there's a lot of stuff out there that's built with what is sometimes referred to as the pin 1 problem, which is comes out of pro audio, and what that means is the shield is not connected to the enclosure, it's connected to the inside circuit. What that is a super highway for RF to get right into the equipment and wreak havoc. Okay, and that's why some pieces of equipment are very hard to debug in a strong RF field. If you can, buy metal equipment, metal enclosures, okay, ground the enclosure, bond it to your grounded bonding system. And if you still have problems, okay, make sure that the cables that you connect to it are shielded, and that the shield is connected to the enclosure on the outside of the enclosure, not the inside and not the circuit board. It should be connected to the outside of the enclosure, which is then connected, bonded to everything else. Okay, and if you're still having problems, that's when the ferrite comes out. The ferrite needs to be the type that works at the frequency where you're having the problem. If you're having problems at HF, you want a type 31 mix, and these are high resistance mixes. They're made for EMI suppression, is what it's called. And at higher frequencies, above 20 megahertz and into the VHF range, use type 43. Most of the cables, you buy a USB cable or something, and it's got a little bump in the cable right behind the connector. That's a type 43 ferrite, and that is designed to help that thing pass its EMI test, but up above, it's up in the VHF range. It doesn't do you hardly anything at HF. There are no EMI rules below 30 megahertz for radiated RF. There aren't. So that's kind of something we have to deal with as HF users. So there's two tips for that. First of all, keep cables short. Buy the shortest one you can get. I think you can buy USB cables down to about 3 feet. Maybe there's some specialty vendors out there that are like 1 foot, but it seems like every time I try to buy cables, they're all 6 feet, 2 meters or something like that, when all I have to do is run them about a foot. It's really kind of frustrating. Use the shortest ones you can, use the high quality ones that are shielded, and use metal enclosure equipment wherever you can. And that includes USB hubs, Ethernet switches, all this kind of stuff. Sure, it's cheaper to go out and buy one in a plastic box, but it's just sitting there. It's just, you're sitting duck with that kind of equipment for RFI problems. Nothing is shielded. The RF can walk right in there, do whatever it wants, and it's very hard to keep from causing a problem. And you might get away with it for a while. You might put it all together and go, hey, no problem here. But, at some point, at the worst possible time, of course, something bad will happen and you'll have RFI you just can't get rid of. So if you've got to use a 3-foot cable and it's only going for a foot, coil that cable up. Use those little tie wraps from bread bags or whatever. Make a little coil, 2-3 inches, and lay that sucker right on the reference plane. That sheet metal that you put under your equipment, just lay it on there. The capacitance between the cable and the fact that it's laying right on this plane where everything is pretty much the same voltage, that helps keep the RF from inducing any current on it. It's not perfect, but it helps. And if you do have loops where you've got to run a cable from one end of the desk to the other, there's always one, and then back again or something like that. You want to minimize the loop area. The amount of voltage that these cables pick up is proportional to the area. So the smaller the area, by coiling it up in short cables, minimizes the voltage. Try to keep your cables close together so there's not much of a loop area there. I have a drawing where I show the piece of pipe, the ubiquitous piece of pipe behind the enclosures, and you just lay all of your cables right on that. And you can use ties or Velcro, or you can even use one of these fancy little cable tray things to keep them all there. And that minimizes the amount of voltage difference between the ends of the cables and between cables. So it's a continual effort. And it's like the old lady said when she saw her first wireless station, says, I don't know why they call this wireless. I've never seen so many wires in all my life. It's exactly right. I mean, I'm looking at my station right here, and I'm counting like a dozen RF cables, and I've got, 6 or 7 power cables and all these, other microphones and USB and digital interfaces and all this stuff. And this is by no means a big station. It's just the way things are. So you have to plan ahead. Start by laying down this sheet of metal, put a nice bus on the back of it, and just make it a practice to buy metal stuff and connect it all together. You're miles ahead of trying to troubleshoot it later.
Short cables, yes. That's. I'm just thinking about my desk downstairs that has cables crisscrossing, going all different directions.
Oh yeah, yeah. It's crazy. Yeah,
it's like I don't want the radio here. Oh no, I want to use this radio for this contest. So I'll just plug it in, sit it on top of the other radio.
Oh yeah. And we've all been there. Everybody's there. But the goal of the book, really, and me talking to you guys, is just to say, look, you've got tools to deal with this stuff. And if you kind of understand what the problem is, and you kind of understand what tools you got to work with, well, hey, you can attack these things. But a single solid ground system made of short, heavy, direct connections works in your favor for all of the requirements: AC safety, lightning protection, RF management, clean audio. You got to bond all your grounds together, keep all of your lightning arresters and stuff together. You have that outside perimeter ground, and man, you're just going to be miles ahead.
Well, that sounds like a kind of nice way to wrap this up. And actually, after listening to this whole discussion, I'm not sure why anything in my shack actually works.
Yeah, it's the bumblebee problem. The bumblebee shouldn't be able to fly, but it does anyway. Yeah. And it's like I said, when I started out, I had that little HW16 in the basement, and I went out and put it in the ground rod. I was supposed to. I said, I don't know why. But it didn't matter. It didn't seem to matter whether the ground wire was on or whether it was off. You get away with stuff, and you get kind of, I wouldn't say sloppy. You just aren't concerned about it because it's not a problem you have to deal with every day. So you just have to try to short circuit out as many of those problems as you can with some basic techniques.
Oh, excellent. I know this is a much bigger topic and we could talk about it forever, but I think we sort of covered our allotted time frame for this. But I do want to ask you if there's anything you want to sort of wrap up with or plug even before we let you go.
Well, I like my books. The grounding and bonding book is, and this is a contract arrangement with me and the league. I'm not making any money off the grounding book. They have sold a ton of these things. The professionals like it. I haven't gotten a single call from a retired electrician. And believe me, if I'd have screwed up something, those guys would have let me know. I had great reviewers. It's a really handy book, and it'll save you plenty of trips to the hardware store. And you know how it is. Each hardware store costs $50, every time you go in. So the book's only like $30. So you're $20 ahead right there. And then I'll plug Ham Radio for Dummies, which is now in its 4th big edition, which is pretty unusual for a Wiley book, a Dummies book. And the book just has legs. It's written for, somebody that said, I got my license, and now what the heck do I do? So it's supposed to be a desktop Elmer, and the 4th edition has a whole lot of revisions in it. So it's available where finer Dummies books are sold. How's that?
That is fantastic. And let me be the first to thank you for spending this time with us. I really appreciate it. I know I only emailed you yesterday, and I kind of thought you would, said, who the hell is this, and why would I want to do that? But
well, yeah, I looked at your email today, and I went, oh, that's nice.
Well, thank you so much for setting aside some time and being here. I think this was really educational. I know it's going to help me going forward with my project where I start getting antennas where they're actually going to be far enough into the sky where I'm going to be worried about lightning strikes and things like that. And getting it done properly when I'm starting at the ground floor is exactly where I want it to be.
There you go. Like Tom Waite said, the large print giveth and the small print taketh away. So yeah, it's one thing after another. But yeah, that's the right problem to have. Okay.
Yep. And for our listeners, we have linked in the show notes the link to the article "Myth of the RF Ground." Of course, your book there on the AWL site, which for members is $22.95, so such a bargain. Non-members is $25.95 for the bonding book. And then we did also find that Lightning Protection Series article on QST and linked to that in the show notes as well. So it's all very good resources. And like I tell everybody, minimally you should have a handbook from the ARRL. It's just, I have 3 copies in 3 different years here. It's a great book, and it has a decent grounding section in it that kind of goes over the basics of everything we talked about. But if you want to get into more information like a deeper dive does, the grounding and bonding book is definitely something I'm going to be adding to my library when I get back in town.
Yeah, it's really addressed a need. I've been very pleased at the response. Just put the information in one place and kind of say it all in the same way so people can understand it, and I think it's doing a service. So that's a good thing. And there's a lot of free information on the ARRL website in the technology area that you can look at, especially in the safety page. A lot of good stuff there.
Fantastic. We've got a couple of bits of feedback to get to, so we'll get to those. But thanks again, Ward and 0AX, for being here. That was highly educational. We really appreciate it, and hope you have a good evening.
So far, so good. All right, guys, 73.
73.
All right, 73. All right, Bill, you want to read one of these?
Sure, I'll read the first one here.
All right.
This is an email from Serge, ON4AA. He says, Dear Russ, Cheryl, and Nerd Bill. Is that kind of like King Bill? Anyway,
sure, you make of it what you want.
All the way from Belgium, I would like to wish you all and the audience a very happy new year, 2022, with loads of good health and a lot of ham Linux fun. I am also writing to let you know that the high-quality OGG stream I used to listen to is currently down. Oh, no. I am currently diverting to the MP3 stream. He's slumming it on MP3, which still works. 73 from Serge, ON4AA.
Yes, and I did respond to Serge on Discord and let him know that all the streams are back up. I actually had to rebuild the streaming server from the ground up just because there were all kinds of issues, and it was getting long in the tooth anyway, So all that stuff is back up and working again. So when you connect to the live streams, you're on a new virtual machine now. Hey. And thanks for the good wishes, and we wish the same to you and yours over there in Belgium. And thanks for being a long-time listener. You've been around forever as far as I can remember. So very good. Our first comment that I could tell from Patreon, like directly through Patreon. So that's cool. This is from Cubicle Nate. He says, of all the great information on this, and this was from the last Weekender episode, he says, I think the dinner plan was the one I could actually action today. So thank you. So there you go. That's a nod to Cheryl for getting that recipe out there and all that. So glad you could do something with that, and hopefully all the other information was a little helpful too. And that is all we've got. There was a press release that I got from Dan, KB6NU, but I don't want to touch on that here. We'll get to that in the next episode because it's a couple months away, so we don't have to jump on it right now. So with that, I guess we are down to the end. So thanks once again to Ward and 0AX for being here and giving an excellent presentation on grounding and bonding. Hope everybody learned a little something. And with that, we'll go ahead and wrap this up. This has been episode number 400.
Well,
what?
We got our
that's
chat
right.
room.
We got the chat room. So it was supposed to get moved to the bottom, and you know what? It did.
I saw you filling it in, so I know you were paying attention to it.
I was paying attention. We got so much going on now. But in the chat room tonight, we had Tony K4XSS, Darren VK60K, Jonathan W5AJQ, Ted WA0ER, and Stacy KB7YS. So thanks everybody for being here. Hope you all have a good week. Well, it's going to be a little longer than that because of circumstances, but stay tuned to the website for more information, and the next episode will be coming up soon. But again, this has been episode number 448 of Linux in the Ham Shack, and for the on assignment, Cheryl W5MOO, I'm Russ K5TUX.
And I'm Bill, NE4RD 73.
Thank you for listening to this episode of Linux in the Ham Shack. LHS is a community-sponsored podcast. The show is recorded live every Thursday at 8 p.m. Central Time, ± QRL. Connect to the live stream at url.bcts.info/LHS Live. Our website is located at lhspodcast.info. You can support the podcast by visiting the LHS Patreon page at patreon.com/LHS Podcast, or by using the contribute list on the homepage. Get in touch via social media. We have a presence on Discord, Facebook, IRC, Twitter and YouTube. Our IRC channel is #LHS Podcast on the Freenode network, and the Discord invite link is url.bcts.info/Discord. You can also drop us an email at info@lhspodcast.info or leave us a voicemail at 1-909-LHS-SHOW. That's 1-909-547-7469. Visit the online LHS merchandise store at shop.lhspodcast.info for fun and fashionable show-themed merchandise. Become an ambassador and represent LHS at a local Linux convention or Hamfest. Email ambassadors@lhspodcast.info for more information or visit the homepage for details. Until next time, remember to always heed your hedonism.